Ozone is a molecule composed of 3 oxygen atoms, O3, and is crucial for life on Earth. Let's explore it in detail. What is ozone? 1. Composition. Ozone is a triatomic molecule, made up of 3 oxygen atoms bonded together. It is a pale blue gas with a distinct odor. 2. Distribution. Ozone is found in various layers of Earth's atmosphere. The majority of Earth's ozone is concentrated in the stratosphere, a region between about 10 to 50 kilometers, 6 to 30 miles, above the Earth's surface, forming the ozone layer. Trace amounts of ozone also exist in the troposphere, the lowest layer of the atmosphere. The ozone layer. 1. Protective role. The ozone layer plays a vital role in shielding the Earth from harmful ultraviolet, UV, radiation emitted by the sun. It absorbs most of the sun's UVB and UVC radiation, preventing it from reaching the Earth's surface. 2. Formation. Ozone in the stratosphere is formed primarily through the interaction of oxygen molecules, O2, with solar ultraviolet radiation. This process leads to the splitting of oxygen molecules into individual oxygen atoms, which can then react with other oxygen molecules to form ozone. 3. Ozone hole. In recent decades, the term ozone hole has become synonymous with a severe depletion of ozone concentrations over Antarctica during the southern hemisphere spring. This phenomenon is primarily caused by human-made chemicals called chlorofluorocarbons, CFCs, which release chlorine atoms in the stratosphere, leading to the destruction of ozone molecules. Uses and applications. 1. Ozone therapy. Ozone has medical applications, and is used in ozone therapy to treat certain medical conditions. Ozone therapy involves exposing the body to ozone, to stimulate healing and improve health. 2. Water purification. Ozone is used in water treatment processes to disinfect and purify water. It is a powerful oxidizing agent capable of destroying bacteria, viruses, and other contaminants. 3. Air purification. Ozone generators are used to purify indoor air by oxidizing airborne pollutants and odors. However, excessive exposure to ozone can be harmful to human health and should be regulated. Environmental impact. 1. Stratospheric ozone depletion. Human activities, particularly the release of CFCs and other ozone-depleting substances, have led to the thinning of the ozone layer, especially over polar regions. This depletion increases the risk of harmful UV radiation reaching the Earth's surface, with potential consequences for human health, ecosystems, and climate. 2. Tropospheric ozone. Ozone at ground level, known as tropospheric ozone, is a major component of smog and can have adverse effects on human health, particularly on the respiratory system. Future outlook. 1. Regulation and protection. International agreements such as the Montreal Protocol have been established to phase out the production and use of ozone-depleting substances. These efforts have led to significant reductions in the emission of CFCs and gradual recovery of the ozone layer. 2. Monitoring and research. Continuous monitoring of ozone concentrations and research into ozone dynamics are essential for understanding its role in the atmosphere and developing effective strategies for its protection. In conclusion, ozone is a critical component of Earth's atmosphere, with far-reaching implications for human health, environmental protection, and climate stability. Understanding its properties, distribution, and interactions with other atmospheric constituents is essential for ensuring its preservation and sustainable use.